In this example, I'm going to show you how to make different types of frequency distributions. We're going to create 4 different types. First, a frequency distribution with classes, a relative frequency distribution, a cumulative frequency distribution, and a cumulative relative frequency distribution. Okay, so we're going to do all 4 of these types of distributions with this set of data right here. These are test scores for a statistics class of 40 students. And these are numerical grades here in this table. So what we're going to do is reorganize this data into a nice frequency distribution, and we're going to use these classes right here. So a frequency distribution is just a nice, clear, organized way to present data, and we're going to organize it into a table. So we're going to label the top of this with statistics test scores, because that's the type of data values that we have. And we're going to separate that into 2 columns. We're going to have the classes over here, which are ranges of test scores. And then over here, we're going to have the number of students with those test scores. Okay, so what I'm going to do is label out our different classes here. We have 40 to 49, the 50s, 60s, etc. And we're just going to go ahead and line these up from lowest to largest. You could also line these up from largest to smallest, either way. So 40 to 49. Okay. So what we're going to do is count the number of scores that are in this class and record that number here. So what we can do is, instead of looking at individual test scores like we have up here, I can investigate them based on which class they're in. So all I'm going to do is flag all of my test scores in this class, and maybe what I'll do is highlight them in yellow, and I'm going to count how many test scores are between 40 and 49. So 1, 2, 3, only 3. Only 3 test scores between 40 and 49. So I can record that here. Another way that you could generate these numbers is by going in order through your data and putting a tally next to each class. But in the end, ultimately, you want to record the actual number here instead of using tallies. But that would be another way to organize your data. So now I'm going to flag everything in the 50s. Okay, so we have just created a frequency distribution using classes over here. So what I want to do now is convert this into a relative frequency distribution. So what's different about a relative frequency distribution? Well, that will show the relation of the number of observations to the total number of observations. So instead of having a count, I will have proportions over here. So instead of knowing it was 3 students, a proportion will tell me what percentage of students got this score. So this is 3 out of a total of 40 students. So the proportions will take into account how many students total. So what I'm going to do is set up my frequency distribution here with labels that are appropriate for the relative frequency distribution. So it is still statistics, test scores, and in the left-hand column we have the ranges of test scores, and we're going to use the same classes. And in the right-hand column we will have the proportion or the percentage, which we're going to call the relative frequency. Okay, so I'm going to use my results from the first part to help me here with the second part. So the way to find a relative frequency is to take how many students fall in this range and divide by the total number of students involved in the data. So instead of reporting that 3 students scored in this range, I will report 3 out of 40, and I will present that as a decimal. So off to the side, I'm going to write 3 over 40, and I'm actually going to compute that decimal. And I'll do the same thing for all these values here. What's great about relative frequency distribution is that it demonstrates the proportions of how many students scored into each class over here. So you can see easily at a glance that 15% of the students scored between a 50 and 59 on this test. So what we're going to do now is create a cumulative frequency distribution. And a cumulative frequency distribution is the sum of the frequency of a particular class and all the preceding classes. So, cumulative means we're going to be adding up our frequencies as we go. So again, I'm going to be working with the frequency distribution that we created in number 1. And instead of just recording the number of students in this category, or number of students in this category, what I'm going to do is record the number of students in this category plus all the preceding ones. So what I'll do here is set up my frequency distribution again. Okay, so again, working from number 1 with my original frequency distribution. What I'm going to do now is note the cumulative frequency instead of just the frequency. So in the first cumulative frequency, we're going to record 3. 3 students scored between a 40 and 49. This is the first category, so it matches. Now over here, what I'm going to record is not just 6 students, but 6 plus the previous. So for the cumulative frequency, we're going to have 9. For the 60 to 69 range, I'm not just going to record these 6 students, but these 6 students plus all the previous. So 6 plus 9 is 15. And so on and so on. So for the 70 to 79 range, the cumulative frequency will be 11 plus 6 plus 6 plus 11. 11 plus 6 plus 6 plus 3. So we get 26. And then for the 80 to 89 range, we'll add 9 plus all the previous. And then in this last category, these 5 plus all the previous. And there we go. So in a cumulative frequency distribution, you get to see how many students scored, not only in this range, but plus all the previous ranges. So 35 students in the class scored an 89 or lower. And all 40 students scored a 99 or lower. Okay, so with cumulative, you want to remember it's the sum of the number of data values in this class plus all the previous. So then in our last example, we're going to create a cumulative relative frequency. So it's going to be cumulative just like this previous example, but with a relative frequency distribution. So what we're going to do is take the relative frequencies and cumulate them. So working with our relative frequencies from number 2, what I'm going to do is not just record the relative frequency, but we're going to make them cumulative. So it's going to include all the frequencies from before. So again, for our first category, we'll just record the relative frequency of 0.075. And then for the next cumulative relative frequency, I will record 0.15 plus the previous. That means 100% of the data is right here in this table. Cool. So in a cumulative relative frequency distribution, what you're doing is you're accumulating, okay? You're taking your relative frequencies and you're adding them up to include not only the relative frequency for this class, but also the relative frequency of all of the previous classes.